Today, guys, we're going to talk about how I made these low tolerance parts pretty quickly. I made all of these in a day. And then I think the order of operations was a little bit clever, if I do say so myself, and how they went together. So kind of started off, except I didn't do them quite in the right order, so there's a couple of problems along the way. You can see I started off with these two are cut in half, or these four have been cut in half from one of these. So what I did is I started off with just a piece of stock and I cut it to this length, and then I faced off one side. And then I came over here and I put the shoulder in. And then I took it and I flipped it in the lathe, and then I faced off all of this, took all the way across, I faced, and then I did all the way across, and I took this down to size just to get rid of the scale on it, because I didn't want that on there. And then I put the other shoulder in, and then I drilled, I think in the first op I actually drilled the hole. It doesn't matter, I could have done it the other way. But I drilled a hole and I step drilled that out. To the diameter of this bit right here. So you can see this bit fits down in here like that. So I took that down, and that is the closest bit I have to the tap size of this. It's like 10 thou off, a little, I think, bigger. It's not a problem. This you'll see will tap into here. And what I'm making is inserts for the table here. Is these things are gonna slide in there, and then they're gonna be welded into place on the bottom and the top, and these actually come up from underneath. So they'll come up underneath. If this is the table, I'll drill a hole in it and then press them up in here. And I have, these are just brought down to 0.81 inches, which is the size of another bit I have. It's my largest bit. So I'll take that and I'll step drill it out, slowly through this metal, and then once I get it there, these will slide up, and then I'll probably pulse weld them in on the top, or maybe just normal weld them, and then weld them in from the bottom, and then probably grind them down flat. We'll definitely grind them down flat. So probably weld them in the top, weld them in at the bottom, and grind them down flat. So this is close to how the finished part actually is going to look. So what I did here is I laid these up, and then I drilled this hole out like this. So this fits, well, that fits there like that. But then I came over here and I put a relief in here with this bit. So this bit slides down in here. So you'll see this slides in, but it doesn't go all the way in like that. And the reason for that is because I only want the thread, it's like only to here. I only want to have to thread part of that because it's really not making it any stronger. They really say just having one thread is enough to actually is about the same strength as having a full thread, because what happens is these don't actually disperse the load completely evenly. So in the failure mode of a thread is one fails and they all fail like a zipper in a line. And so it doesn't really make it that much stronger to have more threading. It just makes it a lot harder to drive the thread through. So these are relieved down to there. So I haven't threaded them yet, but they're going to be relieved like that. And then I'm going to make some more of these that are just going to be bored straight through, and that's how I'm going to bolt it in. So the bolt will slide all the way through that part and then thread into this part, which will be in the table. So these are there's 16 of these pieces, and I need to make 5 more that are a little bit longer, and then some of these are going to be relieved like this, and some of them are just going to be bored straight through so that the bolt fits all the way through. So the way I made these is, like I said, I faced those off, and then what I'm going to do is I'm going to cut these in half, and then I was doing it with a parting tool, but I just cannot part to save my life. I hate it. I hate parting. It's really slow. I even chipped a tool today, I think right here, and I'm like, fuck this. I went over and I cut it. So I need to take these now and chuck them in and face them, and then do that relief drill like I was talking about. The mistake I made with these guys right here is what I really wanted is I want it to be easy to thread the screw into here. So I actually I don't have a countersink tool, I just used a bigger bolt, but you can see there's a little bit of a lip here, and the idea is that if I have the size bolts I'm going to use, having this relief here will kind of guide it into spot and get it in there so that it goes in just easier. I want this to be very rapid and easy to use, super fast and easy to use. And like the idea is I will actually be using my impact driver with a big bolt head on it to drill these in, and I want them to go in really, really easy. So what I'm gonna do with these is once they're actually in place and welded into the table, I'll then go back in with my big bit and try to countersink them. I'll probably get a little bit more chatter because it's not in the rigidity of the lathe. But the idea is I'll just drill a little bit in, and I'll have to do these separately, not on the lathe, when those are done. And then one thing I'm gonna try next, which I haven't finished yet, and I don't have to show you, so you'll have to see it in a future video. But I want to try when I do these tapping of these relief parts, is I'm gonna try tapping them in the lathe. I'm gonna put them in the lathe this way, and then I'm gonna push them this way, and then I'm gonna push with my live center into that hole and push them in like this, oil them up, and then I'm gonna grab this because I don't actually have a good drive system for these, and grab this with a wrench and then just twist them in as I push with the live center. And I've seen a lot of people do that online. I've never actually tried it, so I'm hoping that'll work because threading one of these by hand is kind of a pain in the ass. It's still by hand because it's not going to be power taps, but hopefully it'll be a little bit easier. So there's a lot of work, but I got this done. The surface finish is kind of terrible on these, and that's really because I just wanted to get them done fast. I don't really care about the way they look. They're getting welded inside of a table, and the tolerance does not matter that much because even if they're sloppy, I can weld them into place. It's not a problem. You can see here, I'm cheap, so I was running my carbide until it was like dying on me. So like this side was running my old carbide, and then it was really crapping out on me, and I switched, and you can see this side is shiny. So a couple of these, maybe, I don't know. And that one right there has a nice finish on it. Yeah, I don't know. So they're, like I said, they're low tolerance parts. They don't need to be, high tolerance. The ID on these is probably not super exact either. There's a little bit of play in my tailstock that I don't like. My bits dip into the part a little bit as I push them in. Not always, but sometimes. It's really weird. If you know why that's happening, let me know. But that's pretty much it, guys. This is kind of what I'm working on. Like I said, I need to make 5 more of these guys that are a little bit longer, and then I need to get all of these guys cut in half, then faced off like this, and then come in with the final op of putting in the bigger bit either part way down for the parts that are getting tapped or all the way through for the through holes. And then those are going to get welded into this table to create an angled part that clamps onto the end of this table, and it's an angled plane to this, 90 degrees to this, to allow me to build like boxes better. By the way, this camera angle is old Tony inspired, so thanks for watching.